by the function h equals negative 16 t squared plus v sub 0 or v naught t plus h 0 h of 0 h of naught h naught, however you want to say it. I don't care. There's no one way to say it. What is the h equal? Height. 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 What does the t represent? Anybody? T, time. T for time. How about v sub 0? Velocity. Well, actually, it's initial velocity. And what about h of 0 or h naught, a sub 0, a sub naught, however you want to say it, doesn't matter, they're all proper. What do you initial height? Wow, you guys are fantastic. Okay, what's that negative 16 represent? Anybody know? It's actually, I'll give you the label. It's feet per second. Negative 16 feet per second. Anybody guess? If I drop an object, it's decreasing. What happens when I drop an object? What is that? It's going to fall. Why is it going to fall? Gravity. So it's actually falling at a rate of 16 feet per second. Now, oh, they do have measure and metric. In the metric system, now this is feet per second. The metric system, it changes to negative 9.8. So you have to watch, I think it's meters per second. So you have to, we're the only country in the world that uses standard feet. Why we haven't switched, I don't know. Ask your science teacher. Metric system is base 10. It's so much easier. Everything is divisible by 10. Alright, so you got to watch, like, when you're doing the application problems, because this is all application problems, whether they're talking about feet, the standard system, American system, or the metric system, because you're going to be changing that coefficient of x squared, or in this case, t squared. If you do not change it from standard to metric, you will get the entire problem wrong, even though you may have done all the procedures right. ¿Comprendes? Okay. Number 1. Number 1, a rocket should be is. A rocket is launched directly upward at 45 feet per second from a platform 70 feet high and is given by the equation S of t equals negative 16 t squared plus 45t plus 70. Okay, what is the S of t business? I have no idea what that is. A, what is the initial velocity of the object when it is initially launched? 45. What will be What will be the object's maximum height? Well, how do we figure that out? How do we figure this out? I know. Let's put it in our calculators. Okay, so here's my equation. Now, in math, we kind of like to use all kinds of different numbers here. We're just happen to use S of t, but everything else stays the same. Negative 16. We have to use x squared, unless you want to change it, I don't care. Plus our initial velocity, 45x, plus our initial height, 70. Hit your graph key, and lo and behold, I get some weird picture. So, now, you're going to have to do some thinking on these problems to get this parabola, to get these points. Yes, your parabolas. So, we're at an initial height of 70. If you go to your window key here, it says my y max is 10 feet, 10 units. So if we're starting at 70, we really want to increase that maximum height, don't we? Yeah, we want it at least 70, plus it's being launched, so we need to add like quite a few. So I'm going to increase my y max. I don't know, maybe I'll put 200 in there. If you listen to me, you're going to have to do this on the test and quizzes. So I would pay attention, grab a calculator, and do this with me. I'm going to increase my y value here. Maybe I'll put 300 in there. Then graph it and see if I get my parabola. See how I got my parabola in the window? Because I need that maximum height, which means it's going to be the y coordinate of my vertex. It's going to be my y coordinate of the vertex. Or in other words, my maximum height. No. No, you were talking. Okay, so there's a couple of different ways I can do this. I could try to pick this off of my chart by going to second graph. And again, I'm looking for those y values that start to repeat, and I can try to get that vertex if I'm lucky enough. Let's see, that's not going to happen. So I'm going to have to do some calculations. I'm going to go to second trace. Now this has a maximum, so I need to scroll down to maximum, hit enter, and I have to do that left bound, right bound thing that we did yesterday. Okay. Am I to the left of that point? Well, yes I am. And now it's asking me if I'm to the right of it, so get to the right of our maximum, hit enter. Make sure that my vertex or my maximum's in between those vertical lines, and I'm going to hit enter again. Can you see that, or is it too bright? Zoom in. When it asks me for the left bound, right bound, when I hit the enter button, it puts those lines in. Oh, maybe on your calculators it doesn't do it. Just make sure you're to the left of the point and then to the right of the point. Hit the second trace. button. Second trace, then hit maximum. Number 4. Okay, then it's going to ask me, you want me to give you that point? And my maximum is 1.406250.7. That's my x value, or my time, right? At a maximum height of 101.6 feet. So my y coordinate is 101.6 feet. Okay, that's my maximum height. See my y value? 101.6. Everybody with me? Pardon me? It should not be different. Are you looking here for your x and y values? And what does it say? What's your x? And you put the equation in right? All right, let's do this. Let's do this all over again. Okay, go to your y equals. Put in your equation, -16, negative, make sure you use the negative button, 16x squared plus your initial velocity, 45x, plus 70. Okay, so when you go to graph this, you should get a picture like that, right? Okay, that's fine. All right, do you know how to switch back from, you want a normal graph, just hit zoom standard? If you go to zoom, hit zoom standard, it'll go default back to your regular graph. Okay, so again, gentlemen, do you know how to do this? Because it's on your test Friday. Huh? No, you're going to have to remember how to do this. Okay, so I'm going to go to my window, and I know that I'm starting at 70 feet. It's a rocket that's being launched, so it's going to go up pretty far. I already know it from the first time I did this, it's at 100. So I'm going to go to 150. I want my maximum height, instead of 10, I'm going to put 150 in. Okay? Then I'm going to graph it. And I'm going to try to find that maximum point there, the vertex. Okay? Now pay attention, because this is where a lot of you got lost. I'm going to hit my second key. Okay? I'm going to hit my second key here. And I'm going to hit the trace button, which is actually, it's calculate. Okay? So I want the calculator to calculate my maximum point. Hit enter. Now it's asking me the left bound, right bound stuff. Make sure your cursor is to the left of the maximum. Hit enter. Then make sure your cursor is to the right of that maximum. Hit enter again. And then it's going to estimate where that maximum is. Now, you may get different numbers because your calculator's, giving you the exact point where the pixels may not be picking it up. Your pixels aren't as good a technology as the math is on the calculator. So you may get different numbers here. It should not be all that different. It should be like 1,000th off or something like that. No. I mean, you can, but you're going to make a mistake. Well, it tells you your vertex, your x value. So my vertex here is, my vertex is at 1.41, comma 101.64. That's your vertex. Now remember, we're doing a mathematical model. So my y-axis is actually my height, or my h. My x-axis is my t, or time. Okay, so my maximum height here is 101.6. Now, how many seconds have elapsed when this height will be reached? That's going to be your x value, because x, it represents the time. So it's going to be at 1.4 seconds. Okay? What'd you get? You did something wrong. Either you weren't to the left of the point or right to the point or something. You should have got 1.40. Okay. Then, on your quizzes and homework, you're going to have to fill out some charts. They're just asking you at different times what your heights are. Okay, so at 1 second, where am I going to get this information? When your x is 1, when your x is 2, when your x is 3, what's your y? At the chart. So hit second, graph, that's my chart. Okay, so they're asking me for the time. Again, that's your x-axis, right? This is your x-axis, this is your y-axis. So when my x is 1, my height is going to be 99 feet. Okay. When my x is 2 seconds, I'm at 96 feet. So I'm on my way down already by the time I hit 1 second. And then at 3 seconds, I'm at 61 feet. Now, back in Algebra 1, when you were doing slope, your teacher should have did slope and rate of change at the same time. Okay. So your average rate of change and height, so we're going to do just like slope. It's the change of y over the change of x, delta y over delta x, right? Your Algebra 1 teacher used delta symbols. So our y-axis, again, was our height, so we're going to do the change in height, and our x-axis was the change of time. Okay, so they want from the change of height when time is from 1 to 3. So, remember the slope formula? x2 minus x1 goes in the denominator. So I have 3 minus 1 in the denominator, and my height, 61 minus 99. Huh? I did not. I put 61. .38 over 2. Now, we're doing distance, right? So I can't really use a negative distance, can I? So it's going to be 19 feet per second. That's my rate of change. I'm going to zoom out there. Easy peasy, right? You guys look confused. All right. Number 2. It says an object is dropped from the roof of a 120-foot building. So, what's the 120 foot represent? The initial height, right? The initial height. So this is my h is 0. Okay. How long must it fall to hit the ground? Okay, so we have to develop a function. We're using feet, so it's going to be negative 16t squared. What's my initial velocity? If I'm dropping it, how fast is it going at that point when I'm dropping it? What's the initial velocity? How fast is that? What are we dropping here? An object. Say it's a bowling ball. What's the initial velocity of this bowling ball when I let it go? Huh? Let me ask you this. If I have a bowling ball and a feather, now remember, gravity is what? Constant. Okay, it's a constant number. Without air restrictions, now I'm not going to get into all the different forces of air resistance and all that. So hypothetically, if I drop a bowling ball and a feather, which one's going to hit the ground first? Same time. Okay. So you can't think about which one's heavier. Terminal velocity will change, but not initial velocity. So, how fast is this bowling ball going when I drop it? If you're at a stop sign with your car, how fast are you going? When you, it's not right. Zero. Your velocity is 0. It's not doing anything. Okay. So my initial velocity is 0t. Okay. What's my initial height? 120. Okay. So there's my function. And actually, we can get rid of that middle term, right? Because anything times 0 is 0. So I can simplify it. Okay, let's sketch this out. By the way, you're going to have to do all this homework in class because unless you got a graphing calculator at home. If you have an Android, you can download that Wabbit emo. If you have an iPhone, you have to pay for it. Okay, let's sketch this then. So I'm at this 120 feet. Building. I'm dropping this object off. And it hits the ground. There's my sketch. Okay, so we need to figure out how long it must fall to hit the ground. So what do you think I'm going to do? That's right, put it in my calculator. Now, do this with me so we don't, have all different answers again. Negative 16x squared plus 120. Now let's see if it fits into our window that we had. It should. And there it is. Okay. So it kind of looks like my sketch. Here's my 120-foot building. When is it going to hit the ground? Now, what am I looking for at ground level? That point right there, which is called x-intercept, right? Or the zero or solution to my parabola. I can have up to 2 solutions for my parabolas. So that's my 0. So I'm going to go back to calculate. So I'm going to hit second trace. This time I'm looking for the 0. Hit enter. And it's going to ask me the same thing. Are you to the left of that point? Well, yes, I am. Are you to the right of that point? Well, get to the right of it, hit enter, and then it's going to ask me to guess or estimate, best possible estimation, and my x is what? 2.74. We could just round it to tenths. Seconds. And I'm assuming that that's the answer to B. How long will it take to reach the desired height? They said the ground. I think this is a typo. Questions, comments, concerns? These are on your final exams, these mathematical modeling problems. They're on your final exams, they're on your SAT exams, they're on all, aren't they? That you get an object falling, hit the ground question. They're infamous for being on those standardized tests. That's actually a great score for this school. All right, don't lose your practice worksheet. We